Hello AP Chemistry and welcome to what I promise is the very last video for chapter 16 and 17. Alright, really quick one also, polyprotic titration. So polyprotic, right, H3PO3 is our example here, right. Polyprotic just means that we're going to have multiple protons that we're going to take off, right. So here if we start off with H3PO3, right, and then we add some base, we reach an equivalence point, right, where equivalence point is again where the amount of titrant equals the amount of analyte. But here, my analyte H3PO3, then we make H2PO3, right? And then it turns out, though, as we keep adding base, we can take off another proton and end up with HPO3. Yes? Does that make sense? Okay. So again, polyprotic just means we're going to have multiple equivalence points because we'll take off one proton and then another proton. All right? Okay. Moving along, indicators for titration. So here we have, what kind of titration is this? Right, this is a strong base, right? And to it we must be adding some strong acid. Now, that's why we have here, right, really high pH, right? Not a lot of change, long, steep slope for the equivalence point, yes? All indicators of a strong titration, strong base or strong acid titration. In this case, strong base courtesy of the high pH. Now, because this steep rise is so long and spans so much in terms of pH range, right, turns out that the equivalence point is here, but either of these indicators, phenolphthalein or methyl red, would be appropriate for the titration because we simply need something that's going to change color in the window of this steep rise. Yes, does that make sense? We just need something that's going to change color in the window of the steep rise. All right, so that goes here, right? Phenolphthalein or methyl red would be acceptable. Okay, now if we look here, right here we have, what is this? We're starting off at pH 3, we get this long rise, right? We get this I don't know what it was, a gentle slope here, right? And we get a short rise, which means that this is definitely a weak acid titration, okay? And this is that same weak acid. And again, we're talking about two different indicators, right? Phenolphthalein versus methyl red. Turns out, again, we're looking for the same thing in terms of our indicator, right? It has to change color in that window. But here, in a weak species titration, that window is smaller, right? Characteristic of a weak species, which means that now only one of these indicators is actually appropriate, right? If we use methyl red, that's not going to be effective for catching this little window of pH change, right? Likewise here, if we look starting here, right? pH of 11, and again we get this slope over here, which indicates a buffer region, right? And we get this small window, all of which indicates that this is a weak base, right? And again, same thing. It has to change color in that window. So for this purpose, right, only methyl red would be appropriate. Does that make sense? Right? So when we're picking an indicator, like a color change indicator, it has to coincide with the window of our equivalence point. Yeah? Of the steep rise marking our equivalence point. All right. Thank you for listening. Be good, and I will see you soon. Bye.